units. Why are they important? Units give meaning to numbers. It doesn't do you much good to solve an equation and just have a numerical answer, 5, 10, 23. You need to know, what do those numbers mean? And that's where the units come in. Are we talking apples? Are we talking oranges? Pounds, kilograms, newtons? So there are two major systems of units, the English and the metric system. And by now we all know that the US is one of the only countries that uses the English system. The other two are Liberia and Myanmar. So for this podcast, I'll be using metric the whole time. Our basic units will be meters, seconds, and kilograms. Now, kind of a thing to note here is that kilograms is often used as a weight. So we'll say things like, I weigh 74 kilograms, but that's not actually correct. Kilograms is a unit of mass. If you want to talk about weight, you're going to talk about force, which is in units of newtons. So technically, if you say you weigh 74 kilograms, you have a mass of 74 kilograms and you weigh 725 newtons. So in the English system, the pound is the unit of force, so you are correct to say that you weigh 165 pounds. In the English system, mass is measured in stones, so my mass would be approximately 11.8 stones. You can also use in the English system a slug, but obviously we're not going to be talking about stones and slugs in this course. We're just going to stick with kilograms. So we'll talk about unit analysis here real quick. This is one of my favorite techniques to just kind of do a quick check to see if your problem solving has been correct. So we just talked about force and how that is related to mass. So force is equal to mass times acceleration, and we have units of newtons. And acceleration is our constant acceleration due to gravity, 9.8 meters per second squared. So whenever you're talking about acceleration, your units will be meters per second squared. Mass will be in kilograms here. So if you wanted to say solve for mass, and you're just going through your equation, you better get something like kilograms. So say you just said, is that correct? Is mass equal to force times acceleration? Well, let's see. Do we have newtons times meters per second squared? And a newton is a kilogram times meter per second squared times. So already our units are looking pretty weird here. So we have kilogram, meter squared over seconds, fourth. Does that look like a mass? Nah, not really. So clearly that is not right. So clearly that is not right. So we can try again. Solving for mass. Our units here would be a newton per acceleration. And again, a newton is a force, so that's kilogram. Whoops, sorry. Times meters per second squared. That's a newton. And then we're going to divide that by our acceleration. And when you do all this, you can do the whole thing out. So dividing by that means we're going to multiply by that. And our unit is kilogram. So there we can see we got the right units for mass, should be kilograms. So we know that this is the correct solution of that equation for mass. So again, just a quick way to look at unit analysis. You don't have to worry about numbers. You just kind of go through and see if your units work out correctly. Another example that I like to use that's pretty easy is velocity. distance over time. So again, velocity we all know is speed. So we're all familiar, obviously, with miles per hour or meters per second. You can do anything you want as long as it's a distance divided by time. And this is an equation that we're all solving all the time, even if you don't know it. So if you're trying to run across the street before oncoming traffic hits you, in your head, you're solving, how fast do I have to go to cross the distance of the street in the amount of time before the car and I collide? And in your head, you're doing this calculation. You're not even thinking about it. And you're thinking, I can't run that fast. I better wait. Or how fast is the car going? It's going too fast. I can't make that distance in that amount of time. So you're always doing physics. You just don't even know it. And you're solving these equations just instantaneously. You don't even need it. You don't even need to know the numbers. You just do it and you know. So an interesting point about units that I've always found fascinating is that in 1999, the NASA Mars Climate Orbiter crashed into the surface of Mars because two different systems of units were being used. One team used the English system, one team used the metric system, and they didn't convert the two, and the discrepancy caused the engines of the orbiter to misfire, and it crashed right to the surface and cost $125 million. So you should always check your units.